I work at SciNet at the University of Toronto. I run the supercomputer center as part of one of Canada's compute resources. We're installing a new system, a new cluster, and this new system, we wanted to have a much better I/O capability than we've had in the past. By better, I mean much larger bandwidth, much bigger size, and hopefully a lot better responsiveness, especially IOPS. So in order to do that with spinning disk, it's very hard. You need to have a very, very large file system behind it. And so we opted for this intermediate tier, a fast tier of storage, call it a burst buffer, just for the lack of a better word. And so what we wanted there was the capability of doing a full checkpoint of the system in order of half an hour. So that required enormous bandwidth. The system is going to have it's going to be the order 60,000 cores and about 4 gigabytes of memory per core. So that gives you an order of magnitude of the total amount of memory that we needed to checkpoint. Once that will enable us to run big jobs without wasting time in I/O, without having to wait for a few hours until the checkpoint is done. No, we do checkpoints, but first of all, people don't run on the full system because of the type of system it is and because of the workload on it. We're running 30,000 cores. And the largest jobs that we regularly run are like 4,000 or 6,000. There's less memory per core as well. So people do checkpoint because they need to, but it typically takes them a couple hours if they're doing big jobs. It should really help us enable these large jobs to run. Right now, there's no place in the country, in Canada, that you can run these jobs. We don't have a resource large enough to schedule 10, 20, 30,000 core jobs regularly. And it's very important. We don't allow them to run forever. We keep a very strict limit on the wall time that they can run, so they have to checkpoint.